Excellent.
People. So it's probably a good time to start. So welcome everyone. We have Tamara from Oceanwise, who's new to Connected North at Home, the English side. And today she's going to be looking at, we're going to be looking at the squid from all angles, which is really cool. We've done a session like this with Darren, and it's always a huge hit. And we're really happy to have Tamara here to be talking about squid and their part in nature and how they're used for research, and show us the parts of it. So I'm going to turn it over to you, and we're going to, have a great adventure.
Excellent. Hi, everybody. My name is Tamara. I'm here at Oceanwise at our headquarters here in Vancouver. So I'm on the traditional unceded territory of the Squamish, the Tsleil-Waututh, and the Musqueam Nation. And I spent a lot of time this morning thinking about my relationship to this land and why that's important to me, and thinking about how people have spent since time immemorial building relationships to the land that they're from and that they live on is really important to me. And I think one of the ways that I like to explore the ocean was always to go down to the ocean with my grandpa and dig holes and dig up clams. And taking a look at those animals really inspired me to be passionate about the ocean and to want to care for it. So that path led me to where we are today. And what we're going to be doing today is taking a close look at our squid. As we get into this, I want you to go ahead and type into our chat maybe where you're from and your favorite thing about the ocean, maybe what grade you're in as well, so I have a little bit of idea. Maybe you've done some dissections before or seen some dissections before. That's amazing. I want you to think a little bit about the ocean and about a squid. Can you, if you have paper and a pen nearby, go ahead and draw it. But if not, you've got your imagination. Close your eyes and imagine a squid. Maybe you're picturing something out of SpongeBob. Maybe you're thinking of a kraken taking down a big ship. I'm sure you guys have lots of ideas, because squid are part of a lot of our stories, and a lot of our kind of big myths involve animals like squid. But today, we're going to look up close at these live squid. So let me just switch to screen share. And I want to share with you this one right here. And I'm drawing on it already. That's not what I meant to do. There you go. So you'll be able to see my face, my dissection tools down here in the corner of the screen. And hopefully taking up most of your screen will be my squid, occasionally my hands. Let me know if there's a problem with the audio. Sometimes when I'm running the DocuCam, it goes a little bit iffy. I'm just going to make our chat nice and big before, so that I can hopefully see it and not touch the screen with squiddy hands.
That's that's absolutely perfect.
Excellent, thank you.
Yeah.
So looking here, here's a picture, not a picture, here is a squid. So a lot of times when we see them in scientific drawings, we see them sort of in this position. Their tentacles out, their arms kind of splayed like this. Does anybody know how many arms a squid has? If you don't know, you can use the screen to count. How many are you seeing? Are you thinking 8 or 10? You can type your guess into the chat if you'd like. 1, 2, 3, 4, 5, 6, 7, 8. What about these long squiggly bits? Are those arms? You know what? The difference between the arms and the tentacles is actually suction cups. So the arms have suction cups that go from the end all the way up to the armpit. I'm going to zoom in on this a bit. So you can take a close look. Zoom a little farther, see how that goes.
That looks awesome. Yeah.
So along these arms, I think it's easiest to see on this particular arm. Can you see all those little bumps along the bottom there? Those little bumps, they're actually the suction cups of this squid. And if we look along the tentacles, you'll see they're quite smooth when compared to those arms. So there's one of the little suction cups left off. Those go all up the arm. Whereas with the tentacles, we only see suction cups right here at the bottom. So when we're thinking about squid, what are some things that you know about squid? How do you think squid get their food? So somebody knows that squid tastes good. They're absolutely right. They're one of my favorite treats if I'm at a beach town. Love some calamari. And you know what? They're also a really good treat for a lot of the animals that we care for here at the aquarium. Animals like these sea stars love to eat little bits of leftover squid. Sea urchins will eat little squid. Absolutely. So we eat the squid, but what does the squid eat? How does the squid get its food? The answer is it actually will pull. I'm going to zoom out a little bit for you. They hold these tentacles in close to their arms. When they're swimming through the ocean, they swim about and they use their eyes to find their food. You'll notice that their eyes are a very large portion of their head. So when they see their food, they shoot out these tentacles, boom, and you can see these tentacles reach much longer than their arms. They grab their food with that, and then they pull it back in and use the rest of their arms to hold on to the food like that while they eat it. Now, I know some of you were here this morning checking out what was found in a sea lion's stomach. And some of you saw a squid beak. Why don't you type in the chat if you think the beak is up by the top? You can type a T. If you think it's in the middle, an M. If you think it's at the bottom, type a B. What's your guess? Whereabouts is this squid's beak going to be? Is it this pointy bit at the end? These pointy bits on the side? The squid, its beak is actually right in here, in the middle of all of its arms. I'm going to zoom us in on that so we can see the beak just sticking out. A little more. Can you see that little black spot in the middle? That little black spot, you can see it kind of comes to a point. That is the squid's beak. So the squid's beak is sensibly right in the middle of its arms. That way, when it grabs its food, it goes straight into its mouth. Now, a lot of us mentioned that we love to eat squid. How does the squid hide from its predators. Does anybody have a guess? Type your guess into the chat. How on earth does this animal hide from its predators? What does it have that lets it hide? Oh, I heard somebody say ink, and somebody else said they change colors. You know what? Both are true. Has anybody ever made a cup of tea and then added just a tiny splash of milk to the tea? That tiny splash of milk changed the color of the whole cup. Squid's ink is a little bit like that. They have just a tiny bit of ink, but when that ink goes out into the water, it spreads out and makes a big chunk of the ocean dark and inky looking. That means that the squid can swim out this way or 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 that way, any which way they want, and they will be able to escape from their predator that way. But better than having to do the work and escape from their predator, the best is if their predator never sees them. Did anyone notice these dots on the top of the squid? These dots are actually one of my favorite parts of squid. They're called chromatophores, and they're little cells. Those little cells can expand and contract. So they can grow large or small. Each one of those dots grows or shrinks. So it's kind of like this. If I put one finger in front of the cam, it looks a little bit skin colored, but if I put a bigger space in front of here, it all looks like a hand. So the squid, if it wants to appear white, it'll make all these chromatophores as small as possible. Just a little bit of skin color there. If it wants to appear dark, it will expand them all. A lot of that color there, and it'll appear more like that. So that's sort of how the squid changes its color. You can imagine it with my jacket. If I have it zipped up and closed, I look like I'm wearing all red. If I make those red spots small, it looks like I'm wearing all black, all red, all black. I'm wearing the same thing. I just make the red part smaller. That's how our squid camouflage. They have different layers of these chromatophores that can help them change the light. So these dots are actually what change color. Now this squid isn't alive anymore, so it can't pull those dots closed, but I can help us expand those dots. So what I'm going to do, I'm going to get you to look at this squid. Remember the color you see right now? And I'm just going to rub it a little bit. And when I rub it, what that does is that opens up those little chromatophores and makes it look like they've expanded. And so you can see that area of the squid. It used to all be one color where I rubbed. Now it looks black. So they use that ability. They use that to help them hide in the water. They can either, a lot of people see it as a little bit red. They do have a red layer as well. So their different layers of chromatophores are on top of each other. And those different layers are different colors for them. So it's a pretty cool way of being able to camouflage. It's one of my favorites. But we all came here for a squid dissection, and that means we all came here to look at the inside of this animal. So I'm going to go ahead and flip it over, because that's the way we get in to a squid. Now, you can see this squid is about the size of one finger. So if you're trying to picture this squid at home, or maybe if you're drawing along with what you see, that's a great way to kind of picture or imagine this size-wise. Now, what I'm going to do is I'm going to start by cutting open the mantle. The mantle is this part of a squid. Squids are in the family Cephalopod, and Cephalopod are in the family mollusk, and all mollusks have a mantle. On most, that's the part that would have made a shell in the past. So what I'm going to do is I'm going to get my scissors in here, and when we do a dissection, it's important for us to cut nice and flat. If we cut like this, we're not going to see the insides very well. I'm going to give this a little rotation so it's easier for me to cut. There we go. Zoom out just a little touch for you. Yeah, now you'll be able to see everything happening. Ready? What do you think we're going to see inside the squid's mantle? What kind of organs and body systems do animals need to be alive? What body systems does this animal have? What are your ideas? They maybe have a brain. Oh, spoilers, are you ready to see inside? Oh, they have a small intestine. Maybe it has lungs. Oh, most animals that live in the ocean, they have something different from lungs. Most animals that live in the ocean have gills instead of lungs. I'm just going to open up the top a little better so it's a little clearer here. And bring it down this way because we've got a bit of a shadow. There we go. So, the inside of a squid. Absolutely, somebody guessed what they have instead of lungs. They have gills. Where on this squid do you think the gills are? Are they this part? Were they down near the eyeballs? Here? Their gills, they look a little bit like fish gills, but a little softer, a little wavier. Fish gills have a tendency to be a little bit hard. Their gills are towards the middle. They're actually this part right here. There's one gill. Right there. And the second gill. Is right over here. So now we've just got into the inside of the squid, and I bet you all have a lot of questions. So I'm going to give you guys a moment to ask your questions, and I will go ahead and answer as many as I can. What do you wonder? What do you see? What do you notice? I see somebody's, yeah.
Oh, Lily wants to know, what is the black part in the line?
Perfect. This black part right here, it's actually the squid's ink sac. So that ink sac, remember how we said it doesn't take a lot of ink to turn a big area a different color? This is all the ink that this animal has. It's not very much, but they can remake that ink. So once they've inked once, it takes them a little while to remake more.
Cool.
What other questions do we have?
Delore, I guess he's asking, where does it poo from?
Where does it poo from? Really great question. With a squid, most things come in and out of their body through their siphon. So to show you the siphon, I'm going to zoom out a little bit. Can you see that thing between the squid's eyes? If you're not sure where the eyes are, they're right here. See this little bit here? That is called a siphon. And that is how these squid move primarily. What they do is they suck water up into that mantle, and they squeeze it out through the siphon. And it works like a jet to move them. So squid will use jet propulsion to move around, sucking water into their mantle, pushing it out through the siphon, using these little fins up top to steer, but also their digestive system goes out through the siphon, as does their ink sac. So what I'm going to do is I'm going to get this chopstick in here so you can kind of see how that siphon might work. So you can see how that opens up there. And you can see the ink sac pointing down into it. And you might be able to see there's another little tube. Probably can't really see it. It's hard to see even with your eyes. That goes in here. And it comes out right where this chopstick is about to come out between my fingers. Can you see that?
Oh, yeah.
There we go. So this, there we go. So that's the squid siphon, and that's where things mostly leave the squid's body from. Pretty amazing, right? So that siphon is also part of the squid that we eat when we eat them, is that siphon part. Now, what's your guess? Is this squid male or female? Maybe you can type an M in the comments if you think it's male, an F in the comments if you think it's female. We've got some people guessing male. We've got some people guessing female. Excellent. Let's see all those guesses coming in. I love to see it. I can't quite read your name from this far away, but good job making those guesses. Thank you. I like to see that. So the difference between a male and a female squid is the male squids have sperm and the females have eggs. This squid is a little bit tricky to tell. Up top here, all of this area is where a squid keeps its sperm and eggs, sperm or eggs. The sperm looks very white and like little ribbons. So looking up here, there's no sperm up here. The eggs kind of look like this jelly stuff that we see right here. This squid doesn't have a lot of eggs in it. So maybe she laid her eggs fairly recently. But that's how we tell. We look at this section of the squid. And if it looks like little white ribbons curled up all over the place, then it tells us that's a male. Because squid, how they reproduce is actually really cool. The male passes what's called spermatophore. And spermatophore are a ribbon of sperm. So they pass the spermatophore over to the female. The female puts it in their mantle. And then when the female lays her eggs, she'll use those spermatophore ribbons to fertilize them. And one really interesting thing about squid is she will use multiple different male spermatophore to fertilize her eggs. And that gives the eggs the most genetic diversity. It gives them a really good chance at that species surviving for a long time. So what we're going to look at now is something kind of interesting. Can I get you all to sit up nice and tall wherever you are and slouch? And sit up nice and tall and slouch. And sit up nice and tall. Reach behind your back. Can you feel that bone there? Your spine. Is that one bone or more? It's definitely more than one bone, right? Our spine is a bunch of vertebrae stacked one on top of the other, and that allows us to twist our body, to bend our body, to slouch, to tip over, to do all the fun things that we like to do. Can you make a guess? Does a squid have a spine? If you think yes, they have a spine, you can type V in the chat for vertebrate. If you think they have no spine, can you type I in the chat for invertebrate? Invertebrate is an animal with no spine. A vertebrate is an animal with a spine? I see some conflicting guesses. Some people think it's a vertebrate. Some people think it's an invertebrate. This animal is actually an invertebrate. And what's really cool is instead of having a spine, what it does is it has a pen. I'm going to show you that pen in just a second. So that pen is right here underneath. Now, remember how they use jet propulsion to move? That means if they were soft and squishy, when they tried to swim, their whole body would crumple against that jet propulsion. So they do need something hard in their body to keep them stable and able to stand up nice and tall like I am now. And what it is it's called a pen. It's this part right here on the squid. Let's try to get that out. They're sometimes a little stuck in there. It's an important part of their body. They wouldn't want to just drop it, but here it comes. Can you see this part coming out? It's kind of clear. It's a little bit hard to see. I'm going to lie that right beside the squid. And if you feel your fingernails, it feels very similar to the tips of your fingernails. So this squid pen is called a pen because it looks a lot like those old-fashioned feather pens, except a little bit more clear. Somebody was asking me if I could write with it. Well, I guess I would need some ink to write with it. I wonder where I could get some squid ink from.
And Lily asked why it was so long.
Oh, what a great question, Lily. Why it's so long is if we look at the length of the mantle of the squid, it's the whole length from the very tip of the mantle to the bottom of the siphon. And what that does is that provides stability for the animal when it's swimming. If that pen was only half the size, each time the squid shot water out of its siphon to push itself through the water,
Oh my goodness, we were just getting to the exciting part. What happened? Oh my gosh. Just, I'm sure it's a connection thing, guys, so she'll be right back. This is great. No, it's not just you. I know it'll come back. I can't wait for the ending. This is like a story. Whoa.
It's actually super cool. I'm going to see if I can see them anywhere here.
Yeah, it could be just a connection because she is in the Vancouver Aquarium and they don't have great internet apparently. Well, clearly. It's a cliffhanger. There she is.
Oh, there. Yay.
All of a sudden it got exciting and then you're gone. Okay, we should test your sound again, Tamara. That was so exciting.
there we go. Are we back here? Oh,
Yes. Yay.
sorry about that. I don't know what happened. My internet seemed to have a little glitch there for a second. Glad that I got back to you quickly. So, I think we cut out just as I was talking about why this pen is important. Is that true? Excellent. So this pen is really important because if this pen was only half the size, when the animal shot water out of its siphon, this part right here, half of its body would crumple up. So by having that long pen, the whole length of its body, each time it pushes water out of the siphon, its body can move the most amount possible. So that's why that siphon's really important. Now, somebody asked if this pen could write, but in order to write with this pen, we would need a little bit of ink. So let's take a look at our ink sac right here. What I'm going to do is I'm going to just isolate the ink sac. And if we look carefully, you'll see right at the end here, there's the tube that goes through to the squid siphon. I'm going to get my scissors out, cut that open. I'm going to take that ink sac out and just leave it on the side for a minute, along with my pen. But I want to look at something else before we look at whether the pen will write. I want to take a closer look at the squid's beak. We're going to open up over here. So many arms to get out of the way of this animal's mouth. So we're looking in here, right at that beak again. And I'm going to zoom my camera in a little closer. Whoop, that's a little farther. That's the opposite of what we want. Here we go. So you can see all those chromatophores. You can see that little beak in the center. And what I'm going to do is I'm going to just add a little pressure here. And we'll see the beak slowly start to pop out. Whoop. There you go. So that's the beak. And I'm just going to go ahead and grab these tweezers here so I'm not as covered in squid goo. And can you see, attached to this beak is actually a little string. So the beak has two halves. I'll put one half right here beside us. Put that over so you can see it. But as we look at this half, we notice that it's actually still attached. Huh. What is our mouth attached to? Our mouth is attached to our esophagus. Absolutely, our throat. Our esophagus is inside our throat. So the esophagus is that fancy scientific word for the tube that goes from your mouth down to your stomach. And sometimes you can see, whoops, just how long that tube really can be. There we go. We've removed the beak and we can see the esophagus attached to it. I'm just going to shift my tray a little bit and zoom in even closer. So for me, one of the really cool things about squid is this thing called convergent evolution. It's when two animals that are completely not related to each other come up with the same solution to similar problems. So about some other animals that have beaks. And these beaks are very similar to bird beaks. They'll use them to help bite and rip their food, just the way a bird might. So all those arms help hold the food, and then they can use their beak to rip it. Now, a fact that a lot of people don't know about squid is actually about their brains. I'm going to zoom us back out so we can see. And we're going to get right here. Because the coolest thing about a squid's brain, and I'm going to pop it out right now so we can look. There's the squid's brain. It's actually shaped like a donut, and it goes around the squid's beak. So that donut-shaped brain, imagine the ice cream headaches you would have. If we look farther up, we'll see as I pull on it, it actually moves the squid's stomach. So the part that you see moving there, that I'm not touching, that part, that's right where the stomach is. Now I know you mentioned that squid have 3 hearts. Why would they have so many hearts? How could having more than 1 heart help? They don't have to worry about a heart attack, maybe? They have 3 hearts, which is pretty amazing, 3 hearts. 2 of them are called brachial hearts. If you've ever heard of bronchitis, that means having to do with your lungs. Brachial is having to do also with breathing. So they have one of their hearts at the end of each gill. Let's see if I can show you one. The hearts are quite hard to see once they've been frozen. So this squid came out of the freezer because we were supposed to feed it to some of our animals, but they had eaten enough already. So once it's been defrosted once, we don't feed them back to our animals. Our animals eat food that's just as healthy as the food you and I want to eat. So looking here, what we can see is it's slightly yellow right in here. It's slightly yellow right in here. And that is where this animal's brachial heart is. And the brachial hearts, they control the gills. So kind of like if we had 1 heart for each of our lungs, and then a 3rd heart that's called a systemic heart. And the systemic heart, that moves the oxygen all through the body. Now, squid, they're a little different than us because their blood doesn't have iron in it. It's actually a copper-based blood, which is pretty amazing. These animals are very different from us, but have a really cool lifespan. Now, what I want to share with you next is I want to take a look at another really big part of their body. We're going to take a look over here. Now, if you know what this body part is, feel free to type it in the chat. What are we looking at? This bit right here. What is it? Absolutely. It's the squid's eye. Now, squid, they actually use their vision a lot. They don't only use it to find their food, they also use it to communicate with each other. My favorite thing about a squid is that different patterns on their skin might mean different things. When they're relaxed, generally, their skin is their pale color. When they want to be aggressive, or when maybe they're annoyed with another squid, what they'll do is they'll put a striped pattern along their body. And that striped pattern says, look out, I'm ready to fight. When they've calmed down, they make those stripes go away. Angry, they get all those stripes. Calm, those stripes go away. So their eyes play a really important role. They help them get to know each other and help to know what's happening with the squid around them. We don't know all there is to know about how squid communicate because nobody speaks squid yet, but there's a lot of really cool research ongoing about how squid might learn to change their colors and might learn these communication skills. One of my favorite things about octopus and cephalopods is there's so much still to discover. Let's take a look at their eyes, because their eyes work a little bit different from ours. Their lenses are pretty special because ours the light goes into our eyes and it hits the back of our eyes upside down. They actually have a lens that flips it again so they can see right side up without having to use any brain power. Maybe that's why their brain's smaller than ours. Should we take a look inside this eye? Absolutely, let's. So, the most important thing when doing a squid dissection is keep your mouth closed. Because these eyes actually have some aqueous liquid inside. So that's a little liquid that helps the eye keep its shape. I'm going to slowly cut into it. And you'll see some of that liquid make its way out. Did you see that shoot out like that? It's a liquid that's really similar to the ink that they have. And what I'm doing now is I'm looking about in here to see if I can find, aha, found it. This, all covered in aqueous liquid, is actually the lens. I'm going to pop out of our shot for a second so I can grab a paper towel and clear it off so you can actually see it. This is the part that we're about to look at, but it's too covered in aqueous liquid to actually see. So give me half a second. There we go. Aha. Cleaned it off for you. Harder to see now that it's cleaned off, almost, because it's that kind of pearly color. So I'm going to put it in my hand. So that is the lens from the squid. And I heard that some of you saw these when you were learning a little bit about scat this morning from the sea lion. Yeah, these lenses, they're actually really hard. I could squeeze as hard as I want and I won't squish it. But what I might see is I might be able to see it kind of split the way a pea does into its parts that let it. This one doesn't want to squish. This one's a hard one. They can kind of split in a way that makes them look like a lentil split in half. And that's one of the reasons why their eyes don't have to flip, or their brain doesn't have to flip the light, because their eyes do already. We see somebody who loves to eat fish eyes here in the comment. There's a lot of nutrition in the eyes, so the eyes can be quite good for us to eat. Absolutely. Now, somebody had asked earlier in our conversation if we would be able to write with the squid ink. So I'm going to bring us out over here back to our Squid Ink Sac. And I'm just going to squeeze the ink sac. And we're going to see the ink coming out. You see that all pouring out the end of the ink sac? There we go. Now, it's not a ton of ink, but let's go ahead and dip our pen in it. And see if we can make maybe a little smiley face with it. So the ink isn't super dark, but something that I think is really interesting about this ink is if I take my little bit of water and put the water on the ink, look how quickly it starts to spread out. If we think about our ocean, and we think about that ink being shot out, then it's going to really take a big section of the water and turn it so dark that there's so many particles of ink in it that it'll become very hard for some of our animals to be able to see them. So that combined with that color changing, the chromatophores that we looked at over here, those two things combined, and let's get in closer on those chromatophores. Those two things combined are a really great way to get away from your predators. So my friends, I want to know what you want to know about our squids. What are you curious about?
Jordan has a really great question. We've never heard this one before. What does it smell like?
Oh, what a cool question. Give me a smiley face in the chat if you've ever eaten a squid. Give me a smiley face in the chat if you have been to a beach where you can smell things decomposing. So this animal, what it kind of smells like is it's a little bit sweet smelling, but also kind of sour at the same time. When you smell it, it doesn't make your stomach upset, but also your brain doesn't immediately think, oh, delicious dinner. Because this squid is pretty old. It was slated for our animals to eat 2 weeks ago, and then we put it back in the freezer because they weren't hungry. So this squid, not the freshest squid. I wouldn't recommend eating this particular squid, but this is the species of squid that we eat when we eat them. So if you've smelt calamari, you're smelling a lot of the deep frying, the like bready stuff that's around the calamari. You're not smelling a lot of the squid. So on the like actual squid, when they're fresh, brand new squid, they don't really smell like anything. When they've been sitting for a while, that's when they start to get kind of a little bit sweet, sour smelling, kind of like a combination of dead fish and socks would be my best description of what they smell like.
That's a really good description. Really, really thorough. Let me, Akasha would like to know, this is another amazing inquiry question. Can the squid see through its own ink?
What a really good question. Unfortunately, we don't speak squid, so we can't say, hello, squid, do you see? Can you think of any types of experiments we could do to find out if squid can see? People have worked hard on this question. We don't have conclusive results yet. And what we think is we think that the squid looks around, inks, and then runs to the area where there's no ink. So kind of like if we're playing hide and go seek, you might start in one place and then run and hide. Once you're hidden, you don't need to be able to see as much. You need to see to find that hiding place. So we think that it's probably similar for squid, because the ink works to create a physical block in the water. So kind of like if I put my hands over my eyes, I can't see my screen anymore. Does that make sense?
Yep. And well, Akasha said maybe an experiment would be hiding food in a tank filled with its own ink.
Oh, that could be a really good way to do that. But if we did that, what if the squid just swam around and felt until it found its food? Sometimes designing experiments is the hardest part of science. Being able to answer the questions that we have is really big challenge for all of us, because a lot of our answers answer more than one question. But that would be a really good start to that. Maybe after we did that, we could learn what a squid sign of being hungry is, and we could put just something, because squid, they've been trained to be able to touch a target before they get fed, just like sometimes we train our cats and dogs to do that. People have trained squid to do that. So maybe instead of putting food in the water, we would put a visual target in the water that the squid had to touch to get some sort of reward. That's a really great idea for an experiment. So there's lots of different ways to design them.
Yeah, and Jordan said put something in their eye, or Cameron suggested something with smell. So they're really thinking, they're using their scientist brains to think about ways to test that. Maybe you could attach a digital camera to the squid's eyes. Well, you know what? We know that we attach trackers and cameras to other animals. So yeah, you never know what can happen.
The interesting thing about attaching a camera to their eye is, why would we attach it to their eye? If we put a camera in, we would see what our camera sees, not what the squid sees.
Mm-hmm.
So our cameras work by capturing the light around it. We would see whatever the camera saw. Our eyes work by capturing the light. They work a little bit different. That's why sometimes when you take a picture on a beautiful day and you think it's going to be a beautiful picture, it turns out a little not so good, because your camera processes light different from your brain, and a squid's eye processes light in another way.
Cool. Well, you know, Akasha, it sounds like you would be a great marine biologist, thinking of all these things. And I guess speaking about that, Tamara, how did you become interested in working with, maybe if you stop sharing the screen or the...
Absolutely. I was going to say, let's get rid of this squid so we can chat a little better.
Yeah, because the students might have some other questions. How did you get interested in being a scientist at Oceanwise?
So my journey is a little bit different from most people's, because I didn't know when I finished high school that I wanted to be a scientist. That wasn't really my goal. My goal was to travel the world and be able to see as many things as possible. So I started working at a resort in Florida, and then I went to a resort in the Bahamas and learned how to scuba dive. And when I was there, I spent a lot of time underwater. And for me, what was most fascinating was, even though we'd go to the same place every Tuesday, what I saw was almost never the same twice. Fish definitely have their habits. They have their places that they like to visit. And you could know, oh, you know, at this time of day, on this day of the week, there'll probably be a stingray hanging out here. But you wouldn't always know, and there'd always be little differences. And starting to count and observe those differences is what really got me interested. So I moved to northern Malaysia and became a scuba dive instructor. And as I was teaching diving, people kept asking me all of these really cool questions about the animals that we were seeing. And of course, I was as curious as they were. So I spent a lot of my free time researching these animals, learning more about them, so that when my guests came and asked me questions, I would be able to answer them. And as I got more and more interested and cared more and more about this environment, I started volunteering for citizen science projects. So I would work together with researchers and collect data for them. I know that I don't enjoy analyzing all of the data. That's not my favorite part of science. For me, my favorite part of science is collecting the data. So working and volunteering as a research assistant is kind of my favorite section of science. So currently I'm volunteering with the Howe Sound Research Group. And what we're doing is we're going diving in Howe Sound, and we're doing different surveys to find out what the bioload of Howe Sound is and what kind of animals are actually living there. So a big part of that role is we're going down and just counting fish. There's a lot of different ways that we can get involved in science, even if science isn't your favorite subject. There's lots of different ways to be involved in it.
That is so awesome, just to see how that you took a passion of being a diver and took it in so many different directions. And even today we learned about how they were diving in Alaska and to find information about the animals there. And a week ago, we learned that diving is important, scuba diving is important to become an astronaut. So,
Yeah.
and that's something that is a hobby for lots of people. So that is really interesting that we've had diving come up in so many different ways. So I just want to thank you for a fantastic dissection. Oh, Maddie wants to know, what's your favorite marine animal?
Oh no, that's the worst question, Maddie. I'm so sorry. I don't have a good answer for you because it changes every single day. It's a really good question. My favorite, can I tell you like my favorite 10? No, I won't tell you my favorite 10. My favorite is probably something called a flamboyant cuttlefish. Flamboyant, cuttlefish, Cuttle fish. So cuttlefish are actually related to squid. They're related to octopus. But if you picture an octopus, it spends most of its time right on the bottom, crawling using those arms. A squid lives in the midwater and uses that siphon, jet propulsion, to move around. Now a cuttlefish is kind of in between there. If you picture a football with their tentacles hanging down in the front, they kind of look like this. And the flamboyant cuttlefish is really cool because how it eats is it hypnotizes its prey. It changes the colors on its body from bright purple down to almost black. Bright purple and yellow to almost black. And the colors pulse.
Cool.
And what that'll do is hypnotize a shrimp, and then it'll use those long tentacles, bam, to shoot out and grab the shrimp. Generally is what they eat. So flamboyant cuttlefish is probably one of my favorites.
That's a cool fish. And maybe we'll get to see one day in some of our Connected North at Home adventures. So we're just going to say thank you. And that was really cool and extremely informative. And I loved how patient you were and respectful when you were going through the process and showing every little piece, which was great. And we hope we see you again. Because I know we have more sessions booked, yeah, with Ocean Wise. So tomorrow, ladies and gentlemen, we have experiments with Anna early in the morning at 9:30 Central, 10:30 Eastern on light. And then we're going to meet a pioneer and then listen and learn about the food chain and have dance and art. So we've got a busy day tomorrow and hope to see you guys. And thanks, Tamara, we'll see you later. And thanks, boys and girls. Yep, we have art tomorrow at the end of the day. Yep, with Jamie, learning about how to be a cartoonist. Yep, we'll see you guys tomorrow. Yay!
Thank you.